Doing example 5 from section 5.2. This is a word problem. So we've got, it says find the maximum weekly profit and the price the company should charge to realize the maximum profit. If we're told what the cost function is, that's the cost function. And we're also told the price. This is a demand equation here. So the price is a demand function. So that's P, little p there stands for price. Q is quantity. Okay, so what we need to do here, we're trying to maximize the profit. So we have to remember a couple of things here. In order to get profit, we need to know what the revenue is. Okay, so what's the definition of revenue? Well, revenue is price times quantity, so P times Q. P, though, we have that defined over here. P is actually the demand function, so that's what P is. So P, Q, there's the P, and then we multiply that by Q, and then we distribute it, we get this. So this is the revenue function. Then we've got to remember how profit is defined. I'm going to use a capital P for profit. I hope we can make the distinction here between the capital P and the little p. That's big P, that's profit. So profit, what is the definition of profit? It's revenue minus cost, okay? So we've got the revenue function, that was this. So that's 50Q minus 2Q squared, that's revenue, minus cost, well, that's where the cost function is coming in. This is 100 plus 10Q. Okay, so revenue minus cost. That actually gives us the profit function, which if you simplify this thing, I'll try to put this below here, you get negative 2Q squared plus 40Q minus 100. There is our profit function. That's the thing we're trying to maximize. Okay, now maximizing profit in this case, if you kind of think about what that profit function looks like, I'll try to draw it over here off to the side. Let's think about what that profit function is actually representing, what it looks like. So this is P as a function of Q, meaning that that axis here is Q, this axis here is profit. Q is quantity, so that would be number of items sold. Profit, of course, here would have to be in dollars. So just think about what that function looks like. It's a quadratic. It's opening down. It's got a negative leading coefficient. And that's a negative 100 there, meaning that its P-intercept here is going to be at negative 100. So, and it's opening down, so probably what's going to happen is it's going to go, it's quadratic, so it looks like a parabola, so it's probably going to look something like that. Now, what are we interested in doing here? We're interested in maximizing the profit. So right there is the point we're actually looking for. If you think about what's going on here, this is telling us that there's some Q value here, which I'm going to call Q max, that if I can sell exactly that number, if I sell exactly that number of items, what's going to happen to my profit? Well, it's going to be as big as possible. So what I'm actually looking for here, that's a P value, which I'll call P max. So what we're looking for is specifically that point. How many items should I sell to maximize profit will be this value. And when I plug that back into the function, that will tell me how much profit I actually make. So we hopefully are familiar with how we actually find that point right there. We just noticed that that thing is a critical number. That's a place where the derivative is 0. So everything that we've been talking about up till now, this is where it comes into play. So what we're going to look for now is, well, in order to find that critical number, we've got our profit function. That's what I just graphed here. I need to find the derivative of this thing and figure out where it's 0. That's the critical number stuff that we've been doing. So the derivative of this thing is minus 4Q plus 40. Okay. What do I do with that derivative? I set it equal to 0, so I get minus 4Q plus 40 equals 0. If I move that 4Q over to the other side, I get 40 equals 4Q. So what does that tell me about Q? It tells me that Q is equal to 10. Okay, so that actually is the Q max value right there. Let's go ahead and just notate that. That's Q max. That is the value that we were looking at on the graph over here. So in other words, if I sell 10 items, then I'm going to have a maximum profit. So the question is also actually asking us, well, what is that maximum profit? That's how much we should charge. Sorry, this is the quantity that we should sell to maximize that profit. The question is actually asking both to find the weekly profit and the price that we should charge. So how do we do that? Well, this is how many we have to sell. We want to figure out the price. That was the question. So this thing here, remember, that's the price function. So what we want, that's little p there. That's the price. I hope we can make that distinction. That's price, not profit. So that's 50 minus Q. The Q max value was 10. So 40. So what does that tell us? We should charge $40 for this thing in order to maximize the profit. Okay, then the actual maximum profit, I'm going to make that big P, so this is P max. Again, that's price, this is profit. Little p, big P. The big P max value, well, how do we find that? We know how many we have to sell. We know that we have to sell 10 to maximize this profit. Well, what will the profit then be? In other words, what's that value right there? Well, I have the profit function. That function will tell me what the profit is for any value of P. In particular, the one value of P that we're interested in right now is 10. So if I plug in 10, we'll see what happens. And I think when you plug all this into your calculator, oops, I'm sorry, that should be a 10, not a Q. Let me fix that. Gotta erase this thing. This is kind of a pain to erase. That should be 10 right there. Try to squeeze that in. Okay, so what do we get? 100 times negative 2, that's negative 200, and then there's a 400 there. So that's 400 minus 200 is 200 minus another 100, we get 100. Okay, and this will be in dollars. Okay, so $100 is our maximum profit. Okay, so just to recap, what did we do? We found, well, we were given the cost function, we were given the demand function, the price as a function of the quantity that is sold. We found the revenue function from that because revenue is price times quantity. So there was the price that was given, price here, times quantity is revenue. Distribute that, we got the revenue function. Then we remember that profit is revenue minus cost. So we have our revenue function we just found minus the cost function, which was given up here. Expand that, we get that for our profit function. We notice that that profit function is a quadratic. It's opening downward. It's got an intercept down here of negative 100. And again, if you kind of think about what's going on there, if you don't sell anything, that's what that is. If you don't sell anything, you're making negative profit, right? You lose money. You sell more items, your profit goes up, and then eventually, if you sell too many items, your profit starts to go down. So what we were actually looking for is what's that maximum value. So we found the derivative of the profit function, and we set it to 0. That gave us the critical number. The critical number for that was 10. That critical number actually ended up also being the Q value, the quantity that we had to sell in order to maximize profit. We needed then to use that to figure out the price that we have to charge to get that maximum profit. So we took that 10, plugged it back up in here into the price function. That gave us 40, so that's telling us we should charge $40 to maximize the profit. Finally, to find the actual maximum profit, the P value here, that P max right there, we then plug in that 10 into the profit function. So here's the profit function, plug 10 into there. Simplify that, we get $100. So our maximum weekly profit is $100. Okay.